we have discussed about 2 marks of questions from various chapters. In this video, we are going to discuss about 3 marks of questions, right? And here you can understand that the 27 and 28 number question that will be from chapter number 1, 29 number question that will be from second chapter, 30 number question, in that you will have alternative questions from chapter number 5 and the another one will be also from chapter number 5. 31st number question that will be from chapter number 6. 32 number of question that will be from chapter number 10, and in that order you will also get the chapter number 10. 33 that will be of chapter number 11 and 34 that will be of chapter number 15. Now let's start our journey from 27 and 28 number question that will be from chapter number 1. Okay. As we have studied that in chapter number 1, which type of question can be asked in 3 marks? See, directly they can ask you the one question of 3 marks, or otherwise they can divide the questions like one question of 2 marks and one question of 1 mark, or the 3 questions that will be of 1, 1 and 1, right? So that way also they can divide. So if the question is divided in A, B and C, so simple, that can be completing the chemical equation or it can be balancing the chemical equation. Okay, so such type of journey we have done in 2 marks of question. Activities, like in one activity what we have done, we have taken a flask, in that we have taken zinc granules and we are adding HCl or H2SO4. So that is the reaction of metal when it reacts with acid, so it will release hydrogen gas. Okay, so that is one of the symptoms of chemical reaction. So for that the equations we have decided that Zn plus HCl, it will give us ZnCl2 plus H2. Okay, the states are also necessary to write. So this way we can write the chemical equations for certain different activities. Now let's think about different chemical reactions. As we have studied that there is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and the another one is redox reaction. Now dear, see, understand here, I am in capital. Understand, combination reaction or any of these reactions, types of reaction, how it can be asked in 3 marks. Like what is called, see, this can be asked in 2 marks also and in 3 marks also. Okay, so in 3 marks if it is asked, so what is called combination reaction? Write their examples or explain the activity by which we can understand combination reaction. So we know that which activity is there. There is the activity that in one beaker we are taking CaO and adding water. So it will give us CaOH twice plus heat energy is released. Okay, so that activity we have to write. So if this question combination reaction is asked in 3 marks, so how we have to write? First we have to write the definition of combination. After that we have to give the normal example of combination, and if it is asked that you have to explain the combination reaction with suitable activity, so we have to perform the activity also. We have to write the activity also. Now let's discuss one of the important question for 3 marks, which is the decomposition reaction. Okay, that's very important one, because as you have studied that it is of 3 types, so there is more probability to ask decomposition reaction. So first of all, how we will write decomposition reaction? So simple dear, decomposition reaction means to break down. Okay, so the reaction in which one reactant is broken down into 2 or more than 2 products, so that is considered as decomposition reaction. Like this, suppose we have taken the example, normal example, AB is broken down into A and B, and if ABC is there, so that will be A plus B plus C. Okay, so this way we can understand the decomposition reaction. Now, as we have studied that it will be of three types. So thermal decomposition reaction. Now we can explain what is thermal decomposition reaction. If the breakdown is done by giving heat energy, so that is called thermal decomposition reaction. Okay, for that we have taken example FeSO4. When it is heated, we will get Fe2O3 plus SO2 plus SO3. So here you can see that the 2 oxygen is 4 2s are 8, 3 3 6 and 2 8. Okay, so this was the example of. Also the another example we will have CaCO3. When it is heated, it will give us calcium oxide plus carbon dioxide in form of gas that will be released. So see, in thermal decomposition reaction, we can write these examples. Okay. Also there is some activities. Like two activities are there. First activity is related to this FeSO4. Means in a test tube we are taking ferrous sulfate, and when we are heating that ferrous sulfate, right, it will give us ferrous oxide and evolution of sulfur dioxide, and sulfur dioxide is done. Okay, there is also one activity in thermal decomposition reaction, that is of lead nitrate. In one test tube we are taking lead nitrate and we are heating the lead nitrate. Okay, so from that there will be evolution of gas. That gas is of brown color, and that gas is our nitrogen dioxide. Okay, so that activity also can be asked to you. Means in the topic of decomposition, in different way they can ask you the question that what is called decomposition, write its types and explain the examples of it, or give any examples. So this we have discussed about thermal decomposition, right? Different 2 or 3 activities are there. So it must be clear. If you prepare the equation, so from that you can perform the activity also. Okay, so this will be our concept of thermal decomposition. After that there is electrical decomposition. So as we know that if the breakdown is done by passing electric current, so that is called electrical decomposition. Now in this electrical decomposition we are having a normal example of water, that when electric current is passed from water, it will give us hydrogen and oxygen gas. Now here, see, this is positively charged, so this hydrogen will be taken on cathode, and this oxygen, it will be deposited on anode. So that will be our electrical decomposition. Now the third one, that is our photon decomposition. How we can understand the photon decomposition? So we can write the definition. Now what will be definition of it? If the breakdown, means if the decomposition is done by passing light, generally it may be sunlight, so that is called photon decomposition. The concept will be similar for thermal, electrical or photon, that from one reactant we are having 2 or more than 2 products. So suppose if we take here the examples. Okay, so we will have these 2 examples of AgCl and AgBr, which will give us the decomposition process of AgCl and AgBr, as we have seen. That if in a plate, if we take AgCl or AgBr and if it is kept in sunlight, so after sometimes you will see that the color is changed. Means there will be decomposition, and which is done by light. So that is called photon decomposition reaction. So see beta, this way the decomposition reaction, it is very most important for your board examinations also and for a unit test also, but you have to check that how they have asked the questions. Let me give you some examples of it. That if it is asked that what is called decomposition reaction, write 8 types and give its example. So we have to write the definition of decomposition reaction, then we can explain the normal formula of it, then we can give the types of it, and when it is said about example, so it is better that you take one example of thermal, one example of electrical, or any one example of photon decomposition reaction. Okay, so
start.
So it will be beneficial that if we take one examples of each. Okay. Or in another way, it can be asked to you that explain thermal decomposition with suitable activity. So as we know that there is 2 activity of ferrous sulfate and lead nitrate. So any of one activity you can write. Or explain electrical decomposition with activity. So that activity of decomposition of water, electrolysis of water you have to write, or they can ask you that explain photon decomposition with suitable activities. So the activity of AgCl or AgBr is there, that we can write. So with this way, thermal decomposition from this particular topic, in many ways they can ask you the question which will be related to 3 marks. So you have to read the question carefully and then you have to explain it. Right? Okay. Now, if we talk about displacement reaction, so in displacement reaction also, if we talk about displacement reaction, so in displacement reaction also, in different way they can ask you the questions. Okay. So now let's understand how they can ask you in displacement and double displacement. Okay. So if we talk about displacement, so simple. There is one activity, as we all know that activity, that we are having a test tube. In that test tube, we have CuSO4, which is blue in color. In that, we have kept iron. Okay, just add a little bit of more CuSO4. So what will happen after some time? This color, which was of this liquid, which was of blue color, it will turn green. So that will be our FeSO4. So beta, actually what happens that CuSO4 in aqueous form, which is here, which reacts with ferrous and it will give us FeSO4, which is in aqueous form, and copper. Now there will be the change in nail also. This will be in green color and over the nail there will be displacement of copper. Okay, you can see the copper metal on the iron nail. Now this will happen only this metal is more active in comparison to this metal if it is less active. So more active metal displaces the less active metal from its salt. That is called displacement reaction. So this way also it can ask you that explain displacement reaction with suitable experiment or with suitable example. Okay, so in that case we can write it. Then we know that the another concept that will be of double displacement reaction. Now what will be done in double displacement, and this is also known as precipitation reaction. Okay, so what will be there? So simple beta, we know that we are having one test tube. In that test tube we are having solution of BaCl2. The another test tube, in the another test tube we are having solution of Na2SO4. When it is mixed, when this both are mixed, means it's reaction between BaCl2 plus Na2SO4 in aqueous medium, both are. So in a solution, as a result, we will get precipitates, right? White color PPT is observed. Now beta, what it will be? So simple. There will be a reaction and it will be result like this, that this will be solid and NaCl will get. Okay, so beta, see, this will be insoluble white PP. Okay, so during such type of reaction, insoluble precipitates are produced. So that's why this type of reaction is called precipitation reaction. And here also you can see that the metals are displaced, and both of the metal have displaced the another metal from their salt. So this is called double displacement reaction. Okay, so this way also it can be asked to you in 3 or in 4 marks, right? But most probably it's asked in 3 marks. Okay, then the last one that we can understand, that it is redox reaction. Now see beta, what is redox reaction? So already we have studied that redox is combination of oxidation reaction and reduction reaction. Oxidation reaction means oxygen is added, hydrogen is removed. Reduction means hydrogen is added, oxygen is removed. Now we have to explain this with example. So how we can explain? Okay, suppose we take the example ZnO plus C, it will give us Zn plus CO. Okay, I am taking here this one example. So you can see that from zinc oxide we are getting zinc only. So this is our reduction because oxygen is removed. But if we talk about the carbon, that is our oxidation. Okay, that's our oxidation. And see, in this reaction, oxidation and reduction both together take place. That's why it is considered as redox reaction. Also, some other example of copper oxide is there in our textbook, so you can write that examples. One experiment is also there that you are heating the copper oxide. Sorry, you are heating the copper, and it will give a black color substance. That will be our copper oxide. Okay, and then again, reduction of that copper oxide is also there. So you can take any of example and you can explain what is called redox reaction. So this is also an important one from chapter number 1, which will be asked to you in question number 27 and 28. Now, if we talk about question number 29, which will be from our second chapter. So from points which can be asked to you in 3 marks. After that, the first we can take, that's chemical properties. That is the chemical properties, right? So chemical properties of acids and chemical properties of base. That when acids react with metal, what will happen? Acids reacts with base, that is neutralization reaction. That also it can be explained. Then acids, its reaction with, as we know that base, how it is, right? So base will be metallic oxides. So acids reaction with metallic oxides, so that can be also asked to us, right? So any of chemical properties of acid and base can be asked to us. Let's here we will take the properties and only one example we are going to discuss, right? Rest you have there in your videos and the worksheet, so you can go through it. Like suppose if we talk about acid, so acid plus metal, as we know that it will give us salt and hydrogen gas. Like if we take HCl plus metal, if I am taking Mg, so we will get MgCl2 plus H2. It's very necessary to balance the chemical equation. Okay, so this can be our chemical property, right? Also the another one, if we talk that acid plus base, it gives us salt plus water. So suppose if we take the acid HCl and base if I take NaOH, so it will give us NaCl plus H2O. So this is also our another chemical characteristics, chemical properties of acid. If we take that acid plus metals oxide, it will give us salt and water. So here we have, this will be our third one. We can understand it that HCl plus metals oxide. Suppose if we take Na2O, sodium oxide, so we will get NaCl plus H2O. Okay, so it's very simple that the characteristics of acid. Similarly, there will be some characteristics of base also. So we can understand that characteristics. So the chemical properties, right? It can be asked to you in 3 marks. Okay. Now, the another thing which can be asked to you in 3 marks, that is importance of pH. In any of two importance of pH or importance of pH in tooth decay, that's also the important topic which can be asked to us in 3 marks, that the calcium phosphate layer is there, and if the pH is less, means the acidity is more, so the tooth decay take place. If the food particles are left in our teeth, it can also increase the acidity, means it can also decrease our pH level and it can be result into tooth decay. We can also understand the digestion, in digestion how pH is important, okay, and importance of pH in soil also it can be asked. So such type of questions can be asked to you in 3 marks. Okay, so that is clear. And we can also ask that some of the preparations, right? If we take the example of plaster of Paris. Okay, so plaster of Paris. So actually this can be asked in 4 marks also, but that will be more preferable for 3 marks. That write what is plaster of Paris and its preparation and its uses, because it is the shortcut. So we can say that gypsum CaSO4 into 2H2O, it will break down into CaSO4 into half H2O plus 1 and a half H2O. So this is what calcium sulfate half. So that's hanging hydrate. So the preparation of plaster of Paris and uses of plaster of Paris, that is used in making idols, is used in making toys, right? It's used by doctors. So this way, the questions in 29 number from chapter number 2, which can be asked to you in 3 months. Now, if we talk about the 30th number question, that can be from our 5th chapter, and it's simple that if we list out the questions from 5th chapter in your notebook also, it will be there, that the limitations, right? What was the limitations of new line, right? Or what was the limitations of Mendeleev's, okay? And one of the most important one, that triads of Dominator with suitable example. Okay, so let's discuss that. So let's discuss that triads of Dominator. Now, see, as we know that what will be there in triads of Dominator. What Dominator did, he prepared a group of 3 elements and they were arranged in such a way that the atomic mass of second element is the average of first and third. Suppose we take one example, lithium, sodium and potassium. Every time it's the easiest one. Lithium, its atomic mass is 7. For sodium, that's 23. For potassium, it's almost 39. So according to triads of Dobringer and according to law of Dobringer, the atomic mass of second element is always average of atomic mass of first element and atomic mass of third element. So let's see, its average is coming 23 or not. So simple, atomic mass of sodium is equal to lithium plus potassium divided by 2, that will be average of first and third element. Here we will have 7 plus 39, which is the divided by 2, which will be 46 divided by 2, that is 23. And as you can see that in this group of 3, this will be our atomic mass of sodium. Okay, so this way you can give any of triads. In a textbook different triads are given. You can explain this triads of Dobringer, right? But before that you have to first write the statement, and after that you have to explain that example. So triads of Dobringer, it's also the important one. Okay, if we talk about limitations of Mendeleev. So first of all, Mendeleev has arranged the elements according to their atomic masses. Okay, so what was the limitations of the Mendeleev? So first thing we know that the position of hydrogen was limited, limitation of it. So because sometimes hydrogen behaves as metal, right? So where to keep hydrogen in the alkyl metal group, and sometimes it behaves as non-metal. So where to keep in the halogen group. So the position of hydrogen was the limitation of Mendeleev's periodic table. It was not clear where to arrange hydrogen. Okay, so first limitation was position of hydrogen. We can explain that in detail. After that, position of isotopes. As we know that what is called isotopes, they were having same atomic number, but different atomic masses. So how to arrange these isotopes, like 1H1, 1H2 and 1H3. Now it was arranged according to atomic masses. So for this isotopes of hydrogen, we will require 3 different columns, which was not preferable for it. So the position of isotopes, it is also the limitation of Mendeleev. Mendeleev was not able to arrange this isotopes in his periodic table. And the third limitation, if we talk about it, so the third limitation was the irregularity of it. Means between the first element and the another element, every time the difference of atomic masses was not same. Okay, it was changing, and sometimes the less atomic mass containing element was kept before it. Okay, so all this dissimilarities in atomic masses, right? The difference between them was the limitations of Mendeleev's periodic table. So that can be also the question that what was limitations of Mendeleev's periodic table. Okay, so this way it can be asked. Okay, now from this type of chapter, it's more preferable that instead of asking the whole question to you in 3 marks, they can ask you the questions like this: A, B, and C. And in this, they have kept different VSQs like name the element who is having electronic configuration as 287. So as we all know, so that can be chlorine. Also, in different question, they can ask you that which element is not having 8 electrons in their outermost orbit, then also it is inert. Now think, which don't have 8 electrons, then also it comes in inert. So yes, you are right, that's helium. Okay, and also they can ask you that what is atomic number and atomic mass of calcium. So atomic number of calcium is 20 and atomic mass will be 40 ANU. Okay, so this way different questions can be asked to you in question number 13, which will be related to our chapter number 5. Let's discuss about question number 31. That will be from our chapter number 6. Now, as we know that from chapter number 6, many of difference can be asked to you, right? Like what is difference between vein and arteries, or what is difference between xylem and phloem? Okay. Also, what is difference between autotrophic mode of nutrition and heterotrophic mode of nutrition? Right? As we have studied that in autotrophic mode of nutrition, right? What is called autotrophs? So we have studied that the plants or blue-green algae which can prepare their food by themselves. Auto means they can prepare their food by themselves with the help of photosynthesis process. So they are called autotrophs. Now beta, in photosynthesis what is done? So by carbon dioxide, by water, in presence of sunlight, and by using chlorophyll, plants are preparing their food. That process is called photosynthesis. In various 3 steps, this photosynthesis takes place. The first step, as you all know, that first it will absorb the light energy. So the first one will be absorption of light energy. Second one, that absorbed light energy will convert into chemical energy. And the third one, there will be reduction of carbohydrates. Okay, so in this different steps, photosynthesis reaction can take place. Okay, we can also talk about heterotrophs. So what is called heterotrophs? The organisms who depends on another organism, they are called heterotrophs. In that we will have saprophytic, parasitic and holozoic. Saprophytic means those who depends on death and decay. That will be saprophytic. Parasitic means they depend on another organism. So on which organism they are dependent, that is called host. Okay, and that organism is called parasite. Holozoic means they will take whole of the body or some of the part of the body of the another organism as their food. So that will be our holozoic. Okay, so that can also understand in heterotrophic mode of nutrition. Okay. Now, as we studied the difference between arteries and veins, okay, it's also a very important one, and difference between xylem and phloem. Both of the questions is provided to you in your worksheet, and in earlier videos also you can go through it, the material which is provided to you and the notes which you have prepared. In that, in a proper way, we have taken the discussion of veins and arteries and xylems and phloems. We can also think that our excretory system, if we talk about our excretory system, so our excretory system, it is made up of a pair of kidney, bean-shaped pair of kidney. From that, ureter, and that ureter will be open in urinary bladder, right? So the pair of kidney, ureter, urinary bladder, and last one is urethra. So urine will be stored in urethra, and by contraction of urethra, urine will be thrown out from our body. So this way, excretion, right? It can be excretion in human being, right? In that urine, that can be asked to us in 3 marks. So that will be also the important one. Also, the structure of heart can be asked to us in 3 marks, that it is in size of waist. Okay, it is at left side in our body. It's divided in 4 chambers, and all of the chambers are separated with each other. The upper chambers are called atrium, and the lower chambers are called ventricles, right? So the ventricles means the lower chambers, their walls are thick. So why they are thick? Because it is under the high pressure. Okay, so that all type of questions can be asked to you in 3 marks in our 31st number of question, that will be from 6th chapter. Then if we talk about such type of questions like image formation and all, it will be there. So now the remaining portion, right? If we think that reflection through glass slab, so in that we have discussed that how reflection is done due to glass slab. Okay, so suppose here we are having a glass slab A, B, C, D. The light which enters at the surface of AB, as we know that this is air, this is glass, so rarer to denser medium, it will move towards the normal. Suppose this is a ray which is without refraction, so it will move towards the normal. Now if we talk about this another ray, right, for CD surface. So see, it is from denser medium to rarer medium, it will try to move away from the normal. This both rays, it will be almost parallel to each other. Here, if we will draw it properly, it will be parallel to each other, and this much displacement, that is called a lateral shift. Okay, so as you know that in our earlier videos also we have discussed that we have to draw the figure, then we have to explain the figure, and how lateral shift is done, that we can explain in refraction through glass slab, which will be from our 10th chapter. Okay, also some important questions like magnification, and explain the magnification. So it can be also there. Suppose if we take that magnification, it's a ratio of height of image to height of object. Okay, it can be h dash upon h. Okay, so this will be our magnification. M is equal to h dash upon h. So it can be also asked to you in 3 marks. Also you can give such examples that magnification is equal to 1, magnification is greater than 1, and magnification is less than 1. So when magnification is equal to 1, the object and image both will be same in size. When it is greater than 1, your image will be enlarged than object, and when it is less than 1, so your image will be diminished than the object. Okay, so this way magnification is also the important concept which can be asked to you in 3 marks. Okay, we can also think about refraction. Already we have discussed that what is called refraction. When light enters from one transparent medium to another transparent medium, it changes its direction. That phenomena is called refraction of light, RDT and DRA. RDT, when it moves from rarer medium to denser medium, it will move towards the normal, and DRA, when light moves from denser medium to rarer medium, it will move away from the normal. This concept is also clear in our mind. We can also think about eta. Eta is equal to C upon V. This is our refractive index, right? So refractive index is the ratio of speed of light in vacuum upon speed of light in any medium. Okay. So such type of question can be there in 3 marks from our chapter number 10. Now, if we take our question number 33, in that there will be 3 marks of question from chapter number 11. So which type of question can be asked from chapter number 11? Or the difference on myopia or hypermetropia So as we all know what happens in myopia and what happens in hypermetropia. So first we discuss what happens in myopia. So as we studied that in myopia the eye lens is not able to converge the light ray on retina, so it is converged before the retina. So such type of defects is called myopia. Okay, now what happens in myopia, that also we have studied. So the near object and the object which is far from us, which we can see clearly, that we have to write. See, we are talking generally. So in myopia and another one also. Okay. Hypermetropia. Okay, we are talking generally. So what happens in myopia and what happens in hypermetropia, that we have to write. In which case we are able to see the nearer object clearly or the far object clearly, that also we have to mention. We can also mention that light rays where it is converging before the retina or after the retina, that also we have to mention. If it's asked as a difference, we can also mention that in which case our eyelids will become thick or our eyelids will remain thin. Okay? So such type of points we have to take in it. Okay, we can also take that for solution of myopia and hypermetropia, what can be there. So as we know that the concave lens and the convex lens, so which lens is used, that also we can understand. So see, I am just making it making it as a question for you, because if you will understand this point, so you are able to answer both of the questions, myopia also and hypermetropia also. That's why it's a revision, but almost it is a self-study for you. So go through it, you will get the point. Okay. As you all know that in presbyopia the bifocal lens is used. Some other topics from our chapter number 11, that is atmospheric refraction, twinkling of stars and all. So what we have studied in atmospheric reflection, as we know that our atmosphere is not steady. Okay, so the light ray, when it enters into our atmosphere, due to the changing mediums, it will refract. So that refraction is due to atmosphere, so that is called atmospheric refraction. For that we can understand different phenomena like twinkling of stars. So why stars are twinkling and why it's quite seen up. So as you all know that when light ray is entered into our atmosphere, right? So every time it is entering from rarer medium to denser medium. Okay, so it will, as it moves downside, so its eta will get increased, means its refractive index will get increased, so it will always move towards the normal, and by that, and the atmosphere is also not steady, it continuously changes due to winds and humidity. Sometimes we can see the star with more intensity of light, sometimes it will be less intensity of light, and as they are very far from us, so we can also think as a point object. So as that point object, sometimes it have more intensity, less intensity. Actually it is not changing the intensity, but due to changing the atmosphere, we are having more intensity, less intensity, more intensity, less intensity. That's why we can see that the star is twinkling. Okay, so this way we can understand. As it moves from rarer medium to denser medium, and due to that it moves towards the normal, so that's also right that the star which we are seeing, that will be slight up than its actual position. Okay, so such type of questions can be asked to us in 3 months. That formation of rainbow. Okay, so how it is formed? So that is by the concept of dispersion of light, the small water droplets. It behaves as prism, and the dispersion and the internal reflection. By that we are able to see the rainbow. That can be also asked to us. At which side we are able to see the rainbow? So that will be the opposite side of the sun. So in morning, which side we can, in which direction we can see the rainbow? So as we know that in morning, sun will rise at north, it will rise in east. So as sun is in east, so rainbow in west, and at evening time sun will be at west, so we can see the rainbow at east. So such type of questions can be asked to us from chapter number 15, and it's also almost very easy. So in 2 months they can also ask you the difference between biodegradable, non-biodegradable. In 3 months also it can be there, the difference between biodegradable waste and non-biodegradable waste. Also they can ask you the components of ecosystem, right? So in that we have studied there are biotic components and there is abiotic component of ecosystem. Biotic components are living components. Abiotic components are non-living components of ecosystem. In biotic components there will be producers, consumers and decomposers. While in abiotic ecosystem there will be light, temperature, right? Land, light, temperature, land, wind, water, etc. That will be. In producers there will be plants and living algae. In consumers we can also think about herbivores, carnivores, right, and omnivores. And in carnivores also we can think about lower level of carnivores and higher level of carnivores, right? We can also think about the trophic levels of it. So how the trophic level will be. Okay, so producers, it will be our first trophic level. Producers are eaten by herbivores, so that will be our second trophic level. Herbivores are eaten by lower level of carnivores, so third trophic level, and they are eaten by higher level of carnivores, so that will be our fourth trophic level. So we can also understand about our trophic levels that first there will be producers, there will be herbivores, after that there will be carnivores, and there will be also higher level of carnivores. Okay, so this way we can understand it. See, the direction of flow, it's unidirectional. It will always from producers to herbivores, herbivores to carnivores, carnivores to higher level of carnivores. Right? So we can think such type of questions from chapter number 15, which can be there for us in 3 months. Also, we can understand the flow of energy, that from sun. Producers are taking only 1% of energy, and producers are using that energy for the light process and transferring only 10% of energy to herbivores. The energy which is received by herbivores, they also use the energy for the light process and maintaining the light, and they send only the 10% to carnivores. Same that is done by carnivores, and they transfer 10% of energy to the next topic level. This is called 10% rule. So that is also the important one. Also the biological magnification that we have studied. Right? So with this way, in 34 number of question, that is from our chapter number 15, which can be also a question like formation of ozone and depletion of ozone. So beta, we have also studied in that ozone, how it is formed. So O2, the ultraviolet rays, it will break the O2 into free radicals. This free radical, it reacts with oxygen to give O3. So this way ozone is formed. What is the importance of ozone? It protects us from the harmful ultraviolet rays, and that ultraviolet rays are responsible for skin cancer and the other defects of eye like cataracts and all. Right? So this way, formation of ozone, importance of ozone and depletion of ozone. We all know that CFC, that is chlorofluorocarbon. The compounds which contains chlorine, fluorine and carbon, they are considered as chlorofluorocarbon. So such type of compounds which is much more stable and they are toxic, they are non-biodegradable. So they move upward and they break the ozone which is located in stratosphere. It's said that one chlorine atom can break millions of ozone, right? So this way the ozone particles, it will be broken down, and that is considered as ozone holes. Okay, so such type of ozone layer, ozone holes are seen in Antarctica, and by United Nations Environmental Program, UNEP, right, in 1980s or 1986, there was ban on CFCs. Okay, so this way, formation of ozone, importance of ozone, and depletion of ozone can be also there, the important question in 3 marks from our chapter number 15. Right, so this way, beta, we have discussed our section of 3 marks of question. Right, this is just your reference video. From this you will be able to understand the chapters. Otherwise, you all have done well, right? You all are preparing each and every concept from the chapters, right? You are going through your notes very well. So hope in this video session, our second video session, you got the concept of 3 marks of question, and you will prepare all of the question from your textbooks, from your notes, and from the given worksheets and material to you, and you will do your best. Thank you.